All right, let's talk about question number 5. Insurance company examines a pool of automobile insurance and uh, gathers the following information. All the customer, they will insure at least one car. And 70% insure more than one car. And 20% of customer insure a sports car. Of those customers who insure more than one car, 15% insure a sports car. What is the probability you randomly set a customer insures exactly one car? That car is not a sports car. So this question, you still have two things you're considering. You're considering whether you have one car or not one car, or at least one car, or exactly one car. And another one is whether you have a sports car or not. So I'm gonna use the Venn diagram help me to understand this. So the first one will be more than one car. And because we are deal with all the customer at least have one car, what's inside the circle is exactly one car. All right. I hope you understand that a lot of times we're thinking about treating this as a Bernoulli, if it's either this or that. The overall domain, the overall thing we're considering has to be within the scope of this question. For this case, it's the scope of this is are all the people who at least have one car to deal with automobile insurance. For those people who don't even have a car, they're not, insurance company obviously doesn't deal with them. They're not getting into the general pool of the consideration. That's why in this case is greater than 1 or equal to 1. You do not consider things that equal to 0. Another one is I'm going to put it inside as a sports car. 70% or more than one car. Oh, you know what? I'm going to do this a little bit different. I'll put the inside is greater than 1. Outside exactly equal to 1. Inside is a sports car. Outside, you don't have a sports car. So 70% of customer has more than one car. So more than 1 is equal to 70%. If I have to use a color for 70%, that really represents this whole circle. And 20% insure sports car. And it will be, probability it's a sports car will be 20%. If I have to use a color, a green, this whole circle is green. And all of those who insure more than one car, 15% insure a sports car. What does that mean is, within this 70%, 15% of this 70%, for those who are greater than one car, 15% of them is sports car. Which means probability, it has to be greater than one car, and it's a sports car. That is 70% multiply 15%. And that will give you, that's a 10.5%. And that is right in the middle. That's this particular piece. And that is 10.5%. Now, why we have this question within this particular section is because this 15%, another way to describe this 15%, this is a conditional probability, which is saying the probability that given you it has more than one car, probability sports car is a 15%. And now this actually leads to the general formula for conditional probability, which is A given B is equal to probability A and B over probability of B. Another way to look at this is a probability A and B, which is on the top, is equal to probability A given B times probability of B. Now I'm going to use our example to deal with this. This is saying the probability of it's a sports car, given that it has more than one car, is equal to probability is more than one car and also a sports car divided by probability of all those people have a more than one car. And then I can transform this into greater than one car and a sports car equal to probability greater than one car multiply probability sports car given that a greater than one car. Now I start, sounds like, oh, this is such a long formula, but let me have a correspondence. So this is that 70%. This is that 70%. And I'm going to use this conditional probability, 15%. This is that 15%. And this is that conditional probability. And this was the intersection part. This is that intersection part. and this is that intersection part. They're all actually the same number. And probability B is that more than one car. And the conditional probability. So it's one formula. This is actually the formula you need to know very well. And this is another a way to use it. All I need to do is multiply probability B from both sides. That's just why this question is in there. But hopefully you'll, if you read the question, help you to understand, oh, I just need to multiply 70%, give me 15%. Now, because you know the green is 20%, which is sports cars at 15%, that would actually make this a 9.5%. Because the intersection is 10.5. That's 9.5 to make it all together 20. And before I start moving on all the way down to the question, to the solution, I always trying to figure out, before you do heavy math, always trying to figure out, what are you trying to ask me? What is the probability randomly selected customer exactly one car, and that car is not a sports car. Exactly one car and not sports car, that's actually the red outside. That's what you're asking you to do, calculating this purple one, which is the outside. Exactly one, not a sports one. And that should equal to, now we almost get every piece. We just need to the other moon-shaped blue. That will give us, because total is 70, so this is a 59.5%. Then we can do, is going to be, so what's this plus this is probability equal to 1, or not S, is equal to 70. It's going to be 70% plus that 9.5% is going to be 79.5%. And what's outside? And probability equal to 1 or not S, which is the purple area, is equal to 1 minus 79.5% is going to be 20.5%, and answer is going to be B.